Geometrical meaning of dy by dx. By definition, dy by dx is the limit as delta x tends to 0 of the quotient delta y by delta x. Now let us consider a curve of a function y is equal to fx. Let us consider a point on the curve whose coordinates be xy. And also consider another point on the curve whose coordinates be x plus delta x and y plus delta y. Now if we join these 2 points by a second line, then the slope of the second line is given by the formula y2 minus y1 upon x2 minus x1. Here y2 is y plus delta y and y1 is y. So y2 minus y1 is y plus delta y minus y upon x2 minus x1. x2 is x plus delta x and x1 is x. So x plus delta x minus x. Now we can clear y and minus y, similarly x and minus x, so that the slope of the second line is delta y by delta x. Now we can replace delta y by delta x by the slope of the line. If the line makes angle theta with x-axis, then the slope of the line is also given by tan theta. So delta y by delta x can be replaced by tan theta. So we get limit delta x tends to 0, tan theta. Here for the point xy, the abscissa of the point is x, and for this point the abscissa is equal to x plus delta x. So this increment is equal to delta x. Similarly, this increment is delta y. Now if this point moves along the curve and approaches this point, in that case the second line also changes its orientation. Actually, the second line rotates about the point. Now if the point suppose comes here, at that case the second line takes the new position for which the delta x is smaller than the previous delta x. If the point further moves along the curve and approaches here, in this case the increment delta x further reduces. So if the point moves along the curve and ultimately coincides with this point, in this case the second line also revolves about the point and ultimately becomes the tangent line, for which delta x tends to 0. So delta x tends to 0 geometrically represent that the second line becomes the tangent line. If the tangent line makes angle phi with the x-axis, then we can say that delta x tends to 0 implies theta tends to phi. So we can replace theta delta x tends to 0 by theta tends to phi. So we get limit theta tends to phi of tan theta. Now replacing theta, we get tan phi as the limit, which is equal to dy by dx. Therefore dy by dx geometrically represents tan phi, which is the slope of the tangent line. So dy by dx geometrically represents slope of tangent line.